All right, so now that we have an idea of reference angles, okay, and how to draw angles on a using a coordinate grid, we're going to apply that to triangles now, so we can find the trig ratios of any angle from 0 to 360 degrees, okay, and whether it's positive or negative, that we'll see in a second. So we've used the three trig ratios that you're familiar with: sine, cos, and tan. And the way we remembered it was SOHCAHTOA, which specifically means the sine of any angle in a right triangle is always equal to the measure of its opposite side over the measure of the hypotenuse of the right triangle. And the cosine of an angle is always the measure of the adjacent side in the right triangle over the length of the hypotenuse. And then the tan of an angle is the ratio of its opposite side in the right triangle over its adjacent side. Okay? So we created angles using a coordinate grid. Now we're going to start creating triangles, because then we can do the trig. So if we'll start in quadrant 1. If we draw an angle in standard position in quadrant 1, and remember we always refer to the angle as theta, okay? If we put a point on the terminal arm, and we'll just call it capital P, and it's got coordinates x, y, we can create a right triangle by drawing a vertical segment down to the x-axis. Okay? Now, this is the coordinate x, y. This length here, this horizontal length, will be whatever the value of x is. So this is going to be x. This vertical length of the right triangle is going to be whatever the value of the y coordinate is. Okay? So like if this was the point 3, 4, this would be 3, this would be 4. The hypotenuse, we're going to give a new letter to, we're going to call it r. Okay? Instead of ABC when you use Pythagoras. So now that we've created a right triangle, we can write the trig ratios in terms of x, y, and r. So for example, using this right triangle in quadrant 1 with x, y, and r, the sine would be the opposite angle theta over the hypotenuse, so it would be y over r, according to the letters we've used. What would cosine be? X over r. And tan? Y over x. So. Okay. But what happens if we want to deal with angles, like all the angles in quadrant 1 are between 0 and 90 degrees that we were used to. Okay, but what happens if we want to deal with trig ratios past 90 degrees, all the way up to 360 degrees? Well, we're going to find x and y could be positive or negative, depending on where we draw the triangle. but R is always positive, no matter what quadrant we draw the right triangle in. It's always positive. Because we get R by doing x squared plus y squared and then take its square root. So even if x and y are negative, when we square them, they become positive. That's why R is always positive. All right. If you've got different colors, you may want to use it for this. I'm just going to re-sketch what we did already. Sine theta is y over r, which is a positive value over a positive value. Cosine theta is x over r, and in quadrant x over r. In quadrant 1, that's positive number over positive number, and tan is y over x, both of those are positive. Okay. What if I want to draw a right triangle in quadrant 2? Well, so there's an angle in quadrant 2 between 90 and 180 degrees. How do I draw a right triangle? Well, put a point on the terminal arm and draw a vertical segment down to the x-axis. This time it's going to be the negative x-axis. And what's this here? This is a reference angle. And remember, we use those reference angles to help us find the actual angles. So I'm actually going to use the reference angle in quadrant 2 as part of the right triangle in quadrant 2. Well, what's this length here? What would we call this? What letter? X? Negative x. Because we're in quadrant 2. What would we call this? Positive y, because we're still going up. Remember, I said r was always positive. So what does that mean for the trig ratios? That means in quadrant 2, the sine of an angle will once again be y over r, positive over positive. This is why, if I was to say find the sine of 30 degrees using a calculator, I'd get 0.5. If I use 30 degrees as a reference angle here, the actual angle would be 150. And the sine of 150 is also positive 0.5. They're both positive. Okay? However, the cosine in quadrant 2 is going to be negative x over r. In other words, it's going to be a negative over a positive, which is going to get me a negative answer. Which is why that if you take the cosine of any angle between 90 and 180 on your calculator, the answer will always be negative. The tan will also be negative because it's y over negative x, which is a positive over a negative. So if you take the tan of any angle between 90 and 180, you'll get a negative answer. Hopefully you can start to see the pattern that's happening here. Okay. What about if we have an angle that extends into quadrant 3 between 180 and 270? Well, to create a triangle in quadrant 3, we have a point on the terminal arm, and then we draw a vertical line to the nearest x-axis, and we've got ourselves a right triangle where we're using the reference angle to find the trig ratios. What would this length be? Negative x. What would this point be? Negative y, because we're going down now. And remember, r is always positive. So, our trig ratios, our sine this time is going to be negative y over r, opposite over hypotenuse, which is going to get me a negative answer. Okay? Which is why if you take the sine of any angle between 180 and 270, it's always negative. Same with cosine. It will be negative x over r, which is again negative over a positive, which is going to get you a negative answer. But the tan is going to be negative y over negative x, which is a negative over a negative, which is going to give you a positive answer. So if you take the tan of any angle between 180 and 270, you get a positive answer. Finally, quadrant 4. Put a point on the terminal arm so we can draw a vertical segment to the nearest x-axis and get ourselves a right triangle where the angle we're referring to is the reference angle for the angle between 270 and 360. So what would this be? Positive x. So back to positive x. What would this be? Negative y, and then this would be r. So the sine of any angle between 270 and 360 will be will be negative y over r, which is a negative over a positive, which is going to get you a negative answer. The cosine is going to be positive x over positive r, so it's positive over a positive, which gives you a positive answer. And the tan is going to be negative y over positive x, which is going to get you a negative over a positive, which is a negative answer. That's a lot of trig ratios to remember. Fortunately, we can help us remember it by thinking in quadrant 1, all the trig ratios are positive. In quadrant 2, only sine is positive. The rest are negative. In quadrant 3, only tan is positive. The rest are negative. And in quadrant 4, only cosine is positive. The rest are negative. So if you start from quadrant 1, if you can think of the letters A, S, T, C, like so. Don't worry about this cast rule. Nobody really uses that. People start at A and then they go A, S, T, C. What could that possibly stand for? Well, way back in 2016, one of my classes decided that it stands for All Snakes Talk Crap. All suckers take chemistry. Whatever you want it to stand for, however you can best remember it, go with it that way. Okay? All right. So let's do a few questions related to this, where we're not quite ready to start finding specific angles yet. We're just going to talk about the signs, or we're going to talk about the fractions of sine and cosine and tangent. So here, and I mean, you don't have to draw a diagram, but I've given you a coordinate grid because a lot of times diagram is useful. So we've got a point, -5, -12 is on the terminal arm of an angle in standard position. What point is that quadrant in? Quadrant 3. So let's sketch it. So here we have the point. You don't have to be perfect. -5, -12. So it's going to look like that. Well, in order to find the trig ratios, which we're asked to do, okay, we need a right triangle. How do we create a right triangle? Well, in quadrant 3, we draw a vertical segment up the negative x-axis, and here we go. Now, instead of x, y, and r, we're actually given values. What would this length be if this is -5, -12? This would be -5. What would this length be? But in order to find all the trig ratios, I need the hypotenuse. How would I find that? Pythagoras. A squared plus b squared equals c squared. But in this time, we would say x squared plus y squared will equal r squared. Well, if we square these two negatives and add them together, we get 169 is equal to r squared. Remember, we're solving quadratic equations now. It's not just square root 169. It's plus minus the square root of 169, which is plus minus 13. Question is it positive or negative in this case? It's positive because the hypotenuse is always positive. So we can cross out the negative. It's going to be positive 13. So we've got our three sides. Adjacent is -5, opposite is -12, and hypotenuse is positive 13, which means I can find these trig ratios. What would the sign be? -12, opposite over hypotenuse 13. Remember, we're not asked to find the angles yet. We're just finding the ratios of their trig. Cosine? -5 over 13. And tan? -12 over -5, but we want to simplify that as much as possible, so we just leave it as 12 over 5. And that's all you have to do. We're not finding the angles just yet. You just want to get comfortable with what's positive and what's negative. In this next example, asked in a little bit of a different way. Suppose we've got an angle that's in standard position and its terminal arm, we're told that it's in quadrant 3, and we're told one of the trig ratios. We're asked to find the other two trig ratios. So let's draw a right triangle in quadrant 3. And you can stop with the arrow, you can just do it like this. Okay. Remember, this is theta. Can you determine any of the side lengths?
X would be -3.
X would be -3 because remember, cosine is adjacent over hypotenuse. So we're actually given two sides. And the negative has to apply to the 3 because the adjacent of a triangle in quadrant 3 has to be negative. And then 4 is the hypotenuse. But in order to get the other trig ratios, I need the missing side. And once again, I use Pythagoras. But this time, y is unknown. So it's -3 squared plus y squared equals 4 squared, which gives us 9 plus y squared equals 16, which gives us y squared is equal to 7. What's y? If y squared equals 7, how do we solve for y? Plus minus square root. Don't forget that plus minus. Okay. If you just put square root 7, that's not mathematically correct because there's two answers. However, we have to reject one of them. We're in quadrant 3. Is y positive or negative? So we have to reject the positive answer. Now that we've got all three sides, let's write this over here to remind myself, -7. What sign? Theta. -√7 over 4. Don't go to calculators, okay? Because It's asking you to find the exact values. That means you don't punch it in, because as soon as you punch in a square root in your calculator, you're getting an estimated answer, unless it's a perfect square. And what would tan theta be?
-7
Which would simplify to positive root 7 over positive 3. Good. Okay. So the next couple of steps are going to be actually, well, towards the end, we're actually going to start finding these angles. Okay. But we're going to stop here for now.